Today we are talking with a couple of our student researchers. Very excited to speak with Ann Lee from the University of Virginia and George Lee from the University of Maryland. No relation, just happen to have the same last name, right? Or yes. Anne and George, a paper that you recently submitted was awarded the Best Student Paper Award. So you'll definitely have to talk about that. But first, why don't you tell me just a little bit about you, what you're studying, what you're interested in. So, Anne, do you want to go first?
Hello, my name is Anne. I'm a second year undergraduate at the University of Virginia in the engineering school. I'm currently a double major in computer science and cognitive science. Within cognitive science, I'm mostly concentrating in neuroscience. And yeah, that has been quite the progress. And for research, my research lies mostly in theoretical computer science, and that is in particular approximation algorithms in combinatorial optimization. So far, that has mostly taken place in the setting of computational epidemiology.
Yeah, as many things have been dictated by the little pandemic that we got going on. It's kind of changed a lot of things, but very cool. And George, how about you?
Like Anne, my research mainly lies in theoretical computer science. I've also focused on approximation algorithms for combinatorial optimization. And in addition, I've recently focused on differential privacy and fairness. In class, I'm a math and computer science major. In computer science, of course, I study stuff related to my research. And in math, I've recently mainly been interested in algebra and geometry. In particular, next year I'll probably be taking algebraic geometry, and that field sounds pretty cool to me.
I am so glad it sounds pretty cool to you. I am not a math person, so I think that is great. We need people that sounds really cool to. I think it's really neat that you have definitely an overlap. We think of the Venn diagram of your interests, but then you also have these things on the outside that are very cool and also very relevant as we deal with the pandemic today. But how did you get together for this paper? I'm guessing you share common advisors, probably Madhav and Anil would be my guess.
So I reached out to Mata first, and he agreed to be my mentor, and then he introduced me to the group. I joined in the middle of a previous project first, and then afterwards we moved on to this.
In the previous project Anne mentioned, a friend of mine, Zach, was part of that project, and Arvin told him to find a friend, and that was me. So then I joined the project. Later, Zach moved to working on a startup so he can actually make money. And I stayed in research, and that's how we got to working on this project.
Okay. And what is this paper specifically about?
So basically, the Virginia Department of Health has recently funded some vaccine distribution sites in order to increase accessibility to these vaccines, right? But of course, there is only a limited number of sites that you can place around the state. So our paper studies how to optimally place these sites across the state in order to, I guess, maximize some notion of accessibility. And at the same time, of course, we have some guarantees with respect to fairness because there's disparities between different demographic groups in terms of vaccine accessibility.
And Anne, your interest in neuroscience, cognitive science, behavior, I mean, this also plays a part. So I just love it. George, your interest in the inequity, Anne's interest in the cognitive behavior, it's all linked just beautifully in this problem. So Anne, were there things as you were doing your research that you were surprised to find?
I think the better question would be whether there was anything I wasn't surprised to find, because
Ah,
I really
okay.
didn't have like much familiarity with the research process going into this. And
Okay.
so a lot of it has just been familiarizing myself with how research works as a whole.
Which is critical. I'm guessing grad school is in both of your futures. And so, yeah, understanding that research will put you definitely ahead of your peers in grad school for sure. So you both expressed interest in this subject area, but how did you even find out that this was a subject area? George, when did your interest in algorithm optimization and all these things, when did that spring up?
Oh, I guess all of this has some fundamentals in math, right?
Hmm.
And I guess my parents both hold PhDs in a somewhat related topic, so I guess I've always been on my path here. But before starting college, as I'm sure you know, there's a ton of hype around machine learning. I'm like, I thought I was definitely going to go into machine learning research, right? But then when my friend Zach told me about this opportunity, I'm like, okay, sure. And as I've worked with Arvin, I've gotten more and more interested in theoretical computer science.
Okay. And how about you, Anne?
I think it was a similar process. I predominantly wanted to just get more involved in research in general. And the UVA has quite a lot of resources about research opportunities for undergraduate computer science majors. So I ended up going through the list and just sort of seeing what the opportunities were. In general, I tend to like interdisciplinary topics a lot. I just like it when different disciplines sort of mix together and there's a lot of different types of thought. So the fact that this was in the Biocomplexity Institute really appealed to me personally.
Okay. And how cool is it that your research has real world impact? I mean, I would imagine that was a draw also, right? And what also made this project exciting is you're not talking about something that could happen if, in some fourth weird dimension or whatever. I mean, this is today they're deciding where to put these mobile clinics.
Before going to college, I focused a lot on math, and yeah, there was always that lingering worry. Like math, it was really cool to me, but no one cares. So yeah, working with Arvin in the middle of this pandemic was definitely very interesting. It was nice to see that theory actually does something.
Right. I know. How many times as a mom, do you hear, I'm never going to need this for real life? Why do I have to know how to conjugate verbs or whatever? Yeah, definitely do math. When am I ever going to use calculus in my everyday life? Here you go. And how about you, Anne? I mean, obviously you're interested in neuroscience and computation. Had you even heard of computational epidemiology? Did you know that was a thing?
I knew vaguely, but I didn't really know much going into it in general. And a lot about going into it was influenced by the fact that COVID was ongoing when I was looking for research. So it just seemed like a really relevant field at the time as well.
Right. And going forward, I mean, has this encouraged either of you to continue down this comp epi path, or do you think that you might, learn from this experience, but then apply it in some other direction?
I think I'll definitely continue on this path since COVID is obviously still here. But as we go forward, want to continue working in like the more theoretical side, but having applications in perhaps healthcare. I know one of Arvin's collaborators, John Dickerson, works on kidney exchanges, and I've thought about that,
Oh,
and yeah, that seems like a very important problem as well.
mm-hmm. What about you, Anne?
I think it is a really relevant topic, and I'd also be interested in learning more about it. At the same time, I do want to go more into a direction that's more cog sci relevant,
Right.
especially like neuroscience. I'm particularly interested in the two topics of artificial intelligence in the context of human and biological intelligence. Like there's this sort
Oh,
of feedback between the two topics where
mm-hmm.
you do use computational methods to study the structure of the brain and its organization. But on the flip side, you also use biological intelligence and how the brain is organized to influence or draw inspiration for possible artificial intelligence extensions.
Right. So, as I've spoken to a lot of different researchers, especially researchers who have had long careers, the biggest point that I take from them always is they say yes. All through their career, they've said yes. So, someone gives them some weird opportunity, like your friend Zach, and you said yes. And now here you are. So I love that in both cases, you've said yes to whatever might happen here. And I know for you, no matter what you go into, you will have this experience to reflect on. And it will change probably the way that you deal if you go down the neuroscience path. It will affect that because you'll be thinking, oh, but wait a minute. I remember we did this other thing. And I think it's really cool. Okay, so do you guys have little brothers or sisters?
Yes, I have a younger
Yes.
sister.
Okay. Or little cousins or neighbor kids. Are you familiar with kids? What I would love to hear is for you to explain, like to an 8-year-old. Think of an 8-year-old. So you can't use words like algorithm optimization or words like that because the average 8-year-old is not going to understand what the heck you're talking about. George, I'm going to put you on the spot first. How would you describe your research, and not necessarily about this paper with the mobile vaccine stuff, right? But although it could be that, how would you describe that?
Oh, you give a hard question.
I know.
So, so in life, people need to make a lot of decisions, right? And these decisions are very easy. See, do I eat the cookie today or do I eat it tomorrow? These these questions plague all of us. So naturally, if you have a math problem and you have a calculator, it's a lot easier to solve. Similarly, to solve these decisions, I want to use these computers in order to help solve them. And my work basically uses a computer to better decide these problems.
Yeah. No,
Okay.
I think that's exactly right. Right? Like you teach the computer things or you tell it, "Oh, if you eat too many cookies, this is going to happen." But if you eat a cookie, then this happens. You feel happy because you get the sugar rush. So the computer helps you to decide how many cookies to eat. I think that is a great analogy. That's a good one. All right, Anne, what do you think?
So I have to first commend George on the cookie analogy.
I know. That was great.
Pretty impressive. I think I'd start with the general premise, which is that there are limited resources available in the world. So someone out there has to decide who gets those resources and how you share. And then in the case of our current application, which is COVID-19, we have vaccines. And I think 8-year-olds should know vaccines at this point. So
Yes.
unfortunately, actually, yeah.
Yes.
So there are only a few places that you can get vaccines, but we want the people who want vaccines to be able to get them. So this involves a lot of calculation, sort of like the calculator analogy as well. Calculations are easier if you tell someone else to do it for you. So in our case, we ask the computer to make these calculations so that we can be better at placing these vaccine centers.
I love that. Thank you so much. Those are fantastic answers. And thanks a lot for talking with us today and giving us just a little peek inside the world of an undergraduate researcher.